So midterm review here, number 15. All right, they don't give us a triangle to look at, so we'll just draw one. Won't be to scale necessarily. Let's see, 3y plus 5, y plus 35, and 80. Okay. What type of triangle is it? It's not going to be this one. All right. So I'm going to add these up to 180. Angles of a triangle add to 180 is the theorem. So we've got to get the like terms together and then show work, show our algebra skills here. And what I get is y equals 15, it looks like. So I'm going to use that to plug back in. So what we got is y plus 35. That'll get us 50. So this one's going to be 50 degrees. I think this one's also going to be 50 degrees. Yeah. All right. So what we just found was, okay, the biggest angle's 80, so it's acute. All right, we go by the biggest angle. Now, two of them happen to be the same, which would have made it an isosceles, but that wasn't really a choice. All right, so that's it. All right, in this diagram, okay, so now we're on to congruent triangles proofs. So chapter 4. We jumped a little bit there. All right, HK bisects IL. HK bisects segment IL. So what we get is only IL was cut perfectly in half. We don't know about HK, so let's not do that. Angle H is congruent to angle K. And we should get our own vertical angles. So it looks to me like angle, side. Now, a lot of my students ask, how do you know the difference between angle, side, angle, and angle, side? Okay? So if you have two pairs, just focus on one triangle for a moment. If you have two pairs of corresponding angles, congruent, H and K is one pair, and the vertical angles here is the other pair, ask yourself, is the side between or not? If the side's between, it's angle, side, angle. Two pairs of angles, and you're putting the side in between. In this case, it is not that. Okay? What we have is one of the other two sides. So you've got your angle, but the side's not in between the marked angles. Now, it would be hard, it'd be hard to mark somebody wrong for this one because you could use third angles theorem, but let's not get into that. The intent of this problem was to go with angle, side. That's the most direct method of proof here. Okay. Continue on, given the isosceles triangle below, find the values of x and y. Okay, so when you have an isosceles triangle, the congruent sides are legs, and the one that might not be congruent is the base. Now, the angles, those are base angles. Angles touching the base. This is the vertex angle. So just make sure we know that vocab. To solve this problem, the base angles are congruent. That's the base angles theorem. All right. Now, what we're going to do is we're going to take 7x plus 5, and it's equal to, it's equal to 9x minus 13. And now we're just going to perform some algebra. Okay. This is just, you might do it slightly different, but essentially this is x. So that's one of the values. Okay, so we got the values of x and y. Now I probably need to plug in, to get the other angles so that I can get at the y eventually. So 7 times 9 plus 15, 63 and 15, that's going to be 78. I'm assuming the other one's going to be 70. No, I did something wrong here. 81 minus 13, something's not right. Now there it is. It's 5. It's, sorry. Okay. It's 5, not 15. So that's 68. Okay, and then I'm glad I checked the other one because the other one, 81 minus 13 is 68. So what we've got is we've got 68 there and there. A couple ways we could do this. We could add those up. What we have is 136, and then we're going to do 180 minus 136 to get 44. Okay, so this angle's 44, but we need y. All right, 4y equals 44, y equals 11. There were plenty of other ways to do that problem, but that's how I decided to do it. Okay, prove. Okay, so now we're into chapter 4. All right, we're going to have to complete a full proof. All right, let's go with a plan first. Okay, we always want a pre-proof. Pre-proofing is actually more important than the proof itself. Marking the diagram based on the given, drawing conclusions that we can actually prove. There's a lot of stuff we could say, but not everything can be proven. So we've got to stick to what we can prove. All right, B is the midpoint of AC. Let's start with that. Only AC is definitely cut in half that we can prove. All right, we know the other segments probably going to be those segments are the same. We just can't prove it. So stick to what we can prove. All right, we can prove AB congruent to BC eventually. And this is just pre-proof. I'm just kind of keeping track of what I'm doing. Vertical angles, definitely going to use those. See those right there in the middle? So we're going to use vertical angles. Just reminding myself what I'm going to do. And, oh, they give us angle D is congruent to angle E. All right. So it's looking like an angle side angle proof. Yeah, that's going to be easy. All right. Very good. Nope, it's not angle side angle because the side's not in between. Let's make sure we're careful there. It's actually angle side. Okay, angle side. Good. So I'm not going to do the whole statements and reasons. I'm just going to start writing sentences. I'm going to go after a pair of angles first. Since they give us angle D is congruent to angle E, I'm going to write that statement. I'm going to explain why. Justify it because it is given. Okay. That takes care of one pair of angles, right? And I'm going to go after another pair of angles, vertical angles. Let's do the three-letter path here. Let's go A, B, D. Make sure that you do, in fact, give us a three-letter path. Okay? A, B, D went that way. And let's go C, B, E for the other one. Those are vertical angles. So angle A, B, D is congruent to angle CBE. Because vertical angles are congruent. Okay, so you're identifying the fact that you know that, and that's a theorem in our geometry course. Okay, so I got a pair of another pair of angles. I'm after a pair of sides, but I need help. What I mean by I need help is I got to state that B is the midpoint of AC first. And again, why is that? How can we prove it? Because it is given. So anything that's given is assumed to be true. All right. Now the conclusion from that is that AB is congruent to CB, and that's by one of the rules of geometry. We can call it definition of midpoint. Please make sure that you use midpoint. Don't say bisect, because then all of a sudden I'm going to wonder, where did bisect come from? It says midpoint here, so it's safest to use it there. Okay, now the triangles are congruent. Triangle ADB. We should write it the same way they asked for it. CEB by the angle side, triangle congruence theorem. And nice job, there is one of our proofs. Okay, here comes another one. You know what? That's a 10-minute video, so I will do the next proof on another one.